Okay, do you know that you can use a quadratic formula to factorize?
No, I was not aware.
You're not aware, you can.
No, sir.
And that's what I'm going to teach you guys, because the aim is not to sweat. If there's any tool you can use, why not use it?
Yes, sir.
Yeah. All right. So I'm not going to waste too much time. I'm sure you did a lot of exponents in grade 10, and it's
Yes.
going to be a smooth ride.
Yes, sir.
Okay. Now, how do we go about this expression?
So wouldn't you find their factors? For instance, for 16, it would be 4 to the power of 2.
Okay, yeah, you're right. So this is how I do it.
Mhm.
I consider the smallest primes. This is what these are the primes that they're gonna be asking you about most of the times. 3 and 2.
So,
You know what prime numbers are, right?
yes.
Okay. Numbers that only have two factors, one in itself. That's fine. So now we do trial and error. Okay. I will start with the largest prime. 16 divided by 3. It can't. So I will go to 2. Now 16 divided by 2 is an 8. 8 divided by 2, 4 divided by 2 is 2. Then 2 divided by 2 is 1. So that's my cutoff. So I will have 2 to the power of 1, 2, 3, 4. Sharp.
Yes.
The same thing with 12. I will apply the same thing. But I can see you really know how to do these things. So it is going to be 2 to the power of 4. It's
Times
going to be 2 to the
negative.
power of.
Yeah, it's going to be 2 to the power of 4 multiplied by negative x, which is 2 to the power of negative 4x.
Okay. So, and then 12, how do we break it down?
12 is gonna be 2 to the power of 2 times 3. If I'm not
Okay.
mistaken.
Yes. So if we apply the same principle, I will have this. So we're going to have 3 to the power of 1. You agree? Times.
Yes.
Okay. Because we have 2 2's, right?
Yes.
But they are all in brackets to the power of x plus 1. I think you agree with that.
Yes, sir.
Okay. Then all over 3 to the power of x times 4 is not a prime. How do we break it down?
4 divided by 2 is 2 to the power of 2. Yeah, it's 2 to the power of 2. Negative
Yeah,
x.
that's perfect. This will be 2 to the power of minus 4x times 3 to the power of what?
3 to the power of 1x plus 1.
1x. Yeah, you're right. Okay.
Oh, okay.
It's the same thing.
Yes, sir.
And then we'll have 2 to the power of.
2x plus 2.
That's perfect. And then we will have 3 to the power of x, and then 2 to the power of minus 2x. I think from here it becomes very easy. Then it becomes 2 to the power of minus 4x. Then it will be plus 2x. You agree?
Yes.
You agree?
Yes, sir.
Because these two have the same base. This one also have the same base. So what are we going to do?
Which ones have the same base?
This one and this one.
So you're gonna subtract the exponents.
Yes. Perfect. Okay. Then times 3 to the power of x plus 2. Then, nah, not x plus 2. X plus 1, sorry. Then minus x. This will be minus 4 plus 2. It's going to be 2 to the power of minus 2x. Am I right? No, it's not going to be 2x. This one will be a plus.
Yes.
So the x's will actually cancel.
Yes, sir.
We will have 2 to the power of 2, which is 2 to the power of 2 times, with 3's as well, we will have 3 to the power of 1. I think you agree. So it will be 4 times 3, 12. Well, yeah, I think that's correct. Okay, now 1.1.2. Does it look complex?
A little bit.
Okay, let's give it a try. 1.1.2. Okay. 1.1.2. 3 to the power of 2021 minus 3 to the power of 2017, all divided by 30. The cube root of 3 to the power of 60, 48. Okay, so where do we start? Have you ever encountered this type of problems in the exam?
Yes.
Or Ronewa, have you?
Yes, sir.
Okay, so how do we go about it?
So I'll just take a wild guess. So I remember factorizing out a common factor in the numerator.
Which is how much?
It could possibly be 3 to the power 2000.
3 to the power of 2017. Okay, the common factor will be, we will have 3 to the power of, if you take 2021 minus 2017, you will get 4 times 3 to the power of 2017 minus 3 to the power of 2017. We have something common. You are actually right. Then we have do you agree that a cube root can be treated as something to the power of 1/3? Do you agree?
Yes, sir.
Okay, so this will be, if we are expressing 3 to the power of 6048 in terms of 3 to the power of 2017, what is it that we're gonna get? Okay, 2017, I just wanna do a trial and error. 6048 divided by 2017. 17. It gave me 2 point, how much is it? 2.9999. It means it cannot be divided. So let me try 2017 times 3. I just want to see how close 2017 times 3 is going to be 6048. So 20 times 3 gave me 6051, which, to express 3 to the power of 6048, I can say 3 times 2017, because I got 6051. To get to 6048, I'm going to have to subtract how much, Ronel? From 6051 to get to 6048, because I need to express this exponent and make sure that it's equal to 6048. So I'm going to have to subtract how much? If I subtract 3, do you guys agree? Mamswan?
Yes, I agree.
You agree? Okay. So some people would opt to replace 2017 and make it X. I mean, you can do that too, or just do it straight away. So what we are going to have is, we will have a common factor of 3 to the power of 2017. Then this will be into 3 to the power of 4 minus 1. Do we all agree?
Yes, sir.
Okay. Now inside the bracket, we will have to multiply the exponents, in which, if we multiply the two exponents, how much are we gonna get, Mamswan? We're gonna get 3 to the power of 1 over 3 into 20 into 3 times 2017 minus 3. We will have all divided by 30 into 3 to the power of 1 over 3. If we take the common factor of 3 this side, we will have times 3. You agree? Mamswan, do you agree? There's a common factor between these two expressions.
Yes, sir.
Okay, so we will have 2017 minus, if you take 3 as a common factor, we'll be left with 1. These two will cancel. Then we'll be left with 3 to the power of, let's see, okay, we will have 3 to the power, nah, let me see where I was. Okay, sharp. So we're gonna have 3 to the power of 2017 into 3 to the power of 4 minus 1 all over 30 times 3 to the power of 17 minus 1. I think you will agree with me. Then from here, we will just add the exponents. 3 to the power of 2017 minus, do you agree?
Yes.
Then times 3 to the power of 4, 3 to the power of 4, 81, 81 minus 1, all over 30. So this will be 2017 minus 2017. We're going to have 3 to the power of minus 1 times 80, all divided by 30. 0 cancel 0. Then we will have 3 to the power of minus 1. We are left with 3 underneath. So it will be minus 1 also, because this is 3 to the power of 1, which is going to be a minus, because we now have the same basis. I've already cancelled the zeros, by the way. So we'll be left with times 8. This will be 3 to the power of minus 3, which is how much? 1 over 3 times 3, it's 9. 9 times 3, 27 times 8. So we'll be left with 8 over 27. Okay, let's go to the next one. Now we are solving for x. Or does anyone have a question on the one that we did? Any question?
No.
Okay, no question. Ronnie, no questions? Okay, I assume there's no questions. Okay, solve for x. 3 to the power of x plus 3 to the power of x plus 1 is equals to 36. We will have I'm having a problem with the pen. I go. I'm having a problem with the pens. I wonder what happened. Okay, now it's there. Okay. Just gonna draw a line and divide. Okay. We have 3 to the power of x plus 3 to the power of x plus 1. Is equals to 36. Now, Ronel, are we allowed to add the two powers? Are we allowed? Mom Swan, are we allowed?
No, sir.
So what do we do in this case?
We have to factorize.
Factorize,
Yeah, isn't like take out the common factor,
which is how much?
which is 3x. 3 to the power of x. Oh,
3 to the power of x. Okay, for other people to understand, I know you can visualize what's going on. So do you agree that we have 3 times 3 to the power of x, which is
yes.
equals to 36?
36.
Then the common factor is 3 to the power of x. Then we'll be left with 1 plus
3 to the power of 1 times 1.
3 to, yes. But I mean, if I were you, I was just gonna add the 2. Now I'm allowed. Why? Because if this is a brick, if 3 to the power of x is a brick, it means this one is a brick also. If you have 3 bricks, you can add the 3 bricks and you will get 4 bricks. Do you agree?
Yes, sir.
Okay, because that's essentially what you did there, but it's fine. 4 times 3 to the power of x is equals to
86.
86. Okay, so from here, what can we do?
Can transpose 4 to the other side, which means we'll be dividing 36 by 4.
Okay, 36 divided by 4 is going to give us
9.
9. Now, how do you solve this one?
You bring you bring 9 down to its factor, so it's gonna be 3 to the power of 2 on the other side. So 3 to the power of x is equals to 3 to the power of 2.
Okay, I'm going to do the same thing I did.
With the, yeah.
Yeah. Okay, we're going to do a trial and error. 9 divided by 3, 3. 3 divided by 3, 1. That's our cutoff. So how many 3s do we have?
2.
There's 1, 2.
Yes.
Okay, since the bases are the same, the exponents should also be the same.
Same.
I think we all agree. That's perfect. I feel like this was a smooth ride. Eh? Okay. Yeah, but it's fine. Let's go to the tough ones. Yeah. This is what you guys are doing currently.
Yes, sir.
Okay. We have minus x squared minus x. Minus x squared minus x is equals to 5 5 minus 2x minus x squared. 5 minus 2x minus x squared. So from here, what do we do? Ronel, what is the first thing to do? Mamswan?
Sir, I'm not sure.
Grouping. You agree?
Yes.
These two must be grouped. So in order for us to do that, because we are dealing with quadratic functions, if you want to apply your quadratic formulas, it's better to take everything to one side. So the best way to do that, if I take x squared minus x squared to the other side, I will have, when it comes to this side, it will be plus x squared. Do you agree?
Yes, sir.
And if we take minus 2x, it's going to be, if we take it to the other side, it has to change, it has to get a passport, it has to change, get something new, which is a positive. Okay, it's a positive 2x. Same thing with the 5. It's a plus 5, it's going to be a minus 5. That's perfect. It's all equals to, what are we going to be left with?
0.
0. Okay. Here we're going to have a 0, and we're going to be left with minus, oh no, not a minus. We're going to have x minus 5 equals 0. So what do we do now? How do we solve for x?
We transpose 5 to the other side.
Perfect, which is going to be? Right. Yeah, so I actually put this one intentionally, because I know some people were going to panic and try to apply some quadratic shenanigans, only to find out that the resultant of this whole thing is just a linear solution. But it's fine. Let's go to the second one, to the third one. 1.5. 1.5, we have a 1.5. I think this will be a little bit tricky. Ronel, what is a SAD? What is a SAD? Mamswadi, what is a SAD? What is a SAD? What are SADs? Or SADs? I don't know what you call them.
Is it not the square roots of numbers that cannot be simplified?
No. So SADs are all the expressions that have square roots. All the expressions that have a square root, wherever there's a square root, that's a SAD. Where you are dealing with a SAD. Wherever you see an umbrella, SAD. That's how it is. It's equal to minus x. I think this will be a bit tricky. So with SADs, we have to make sure that we remove all the umbrellas or all the square roots that we see in the expressions. So how do we go about this one, Ronel? What is the best way?
Hello.
Yeah.
Okay, so that can you, I think you can clear both sides.
Okay. We can do that as well. But okay. We can do that as well. There's so many ways to kill a cat. One could have taken this one to the other side as well. It all works. But let's see where it lands us. So we will have x minus 1 minus 1 squared is equals to minus x squared. You agree? What you do on this side, you must do it on the other side also. So what we will have as a result is how do we solve the squared binomials? So, Mamswali, what do you do if you have a square binomial? Do you break it down?
Yes, usually I break it down. So I
Okay.
expand it.
Let's see. In this case, if you break it down, you're gonna have a squared plus ab. You agree?
Yes.
Plus another ab plus b squared. You will have a squared plus 2ab plus b squared. So why go the long route when there's this short route which says take give the first term a square and the second term a square. Then the middle term will be the first term times the second term with its sign times the exponent, which is going to be plus 2 times a times b, 2ab. That's what I do. Whenever you meet a binomial, a binomial square. So in this case, I'm going to do the same. I'm going to give the square root a square. That means I'm taking out the umbrella. Then I'll be left with, I'm going to square the second term and it will give me plus 1. But what is it that is going to be in the middle? What is going to be in the middle will be, it will be plus 2 into the square root of x minus 1 times minus 1. So altogether, this will be x minus 1 plus x minus 1 minus 2 square root of x minus 1, then plus 1. That's what I'm going to get. And then this is all equals to x squared.
I have a question.
You agree?
I have a question.
Hmm?
I have a question.
Another?
Question. So does the third not automatically cancel out?
Which one?
Yeah, the third that we put in brackets there and we squared it. Does the square not automatically eliminate the third?
No, it doesn't. No, it doesn't. But Mom Swan, do you see why I'm saying that it doesn't? It only. Oh, you're right. Oh no. It doesn't. It will only lift up the square root of the first term, because remember you have this term and this one.
Yes.
It doesn't, because this is the square of a binomial. This is a binomial square.
Okay.
This is a binomial square. So this is what you're going to be left with. So again, that's why I said I don't think I was going to go this route. You can actually get to the answer, but I don't think I was going to go through this route. The thing that I was going to do was, if I have the square root of x minus 1, then minus 1 is equals to minus x. I was going to take 1 to the other side. Okay. Then I will be left with x minus 1 is equals to x, minus x plus 1, which is simply the square root of x minus 1, which is equals to minus of x minus 1. Do you agree?
Yes.
Then if we put the square root both the squares both sides, we're going to be having x minus 1, which is equals to x minus 1 squared. Do you agree on that one?
But so what happens to the negative that you factored out?
Negative 1 squared will give you a positive 1. Do you agree?
Oh. Okay.
Do you
Yes.
agree? It will be swallowed by a square because it's negative times negative.
Okay.
Okay, now from here, I mean, don't be tempted to cancel out. Why? Because you're going to be canceling out possibly one of the solutions that we want. So the best way is to not cancel, but to resolve what is in the brackets, which is going to be, we will have x minus 1 is equals to x squared minus 2x minus plus 1. Do you guys agree with that statement, Ronel?
Yes, sir.
Okay. So we're going to take everything to one side. So the best way is to take all this and take them to the other side and be left with 0. We will have x squared minus 2x minus x plus 1 plus 1. This will be x squared minus minus 3x plus 2. Now, how do we solve, or how do we factorize this one? Again, I urge you guys, given that you have learned the quadratic formula, whenever you get a quadratic expression, just use the quadratic formula. It's very simple. So it's a minus, Ronel, what is it? Minus b plus or minus the square root of is it correct?
Yes.
Over 2a.
Okay.
Okay. This will be, so x will be minus, our b value is minus 3 plus, I'm going to first do the plus section, which is going to be the square root of b is 3 minus 3 squared minus 4 times a is 1 times c is 2. We agree. This is
Yes.
the value of a, and minus 3 is the value of b. Then 2 or plus 2 is the value of c. all divided by 2 times, what is the value of A?
It's 1.
1. Okay. And then, because we are dealing with a quadratic, there's an or. That's why it's a plus or minus. We will have minus 3. We will have minus of minus 3. But because now it's a minus, we're going to repeat the same thing, but with a minus. Minus 3 squared minus 4 times 1 times 2 all over 2. Now, let's see what we have. We're going to have 3 plus the square root of, okay, 3 squared is going to be 9. Let me see what I'm going to get. 9 minus 4 times 2, 8. So I'm going to have the square root of 1 all over 2. Or 3 minus the square root of 1 all over 2. I will have 2 solutions. So the second solution, or the first solution will be, what is the square root of 1?
It's 1.
Okay, do we agree with that answer? 3 minus 1,
Yes.
2 over 2, which is 1. 2. So we have 2 solutions. We actually have 2 solutions. This is very interesting. So the first solution is x equals 2. Or the second solution is x equals 1. We all agree?
Yes.
Okay. So I have said earlier on that, you know what? You can actually use a quadratic formula to factorize, because why not if you can? The aim is to get the answer. Who cares if where you got the answer from? Okay, this is how you factorize. It's a trick. You just take 2 to the other side. It will have a minus. This is equals to 0. The same thing here. X, if you take 1 to the other side, it will be minus 1 equals 0. These are your factors. In case if you get an expression which is hard to factorize, this is how you factorize. But this was not part of the solution. I was just showing you guys how to factorize. We were looking for solutions using the quadratic formula. Then the next question gonna be x minus 3. I can see that we don't have time anymore. Ne? So I'm gonna do a quick repeat fire questions so that you guys can get an understanding of how quadratic equations operate. Ne?
Yes, sir.
Have you guys done graphs? For instance, parabola.
Yes, sir.
Yes, sir.
Okay. I'm not going to do an equation of that function, but let's say if that function has had an equation. When you solve that equation, how many solutions were you going to find? Mamsan.
So is it not 2?
Why?
I don't know.
So would we
Okay.
not have to find 1 point for the x coordinate and 1 point for the y coordinate?
No. Solutions are x-intercepts. Solutions are x-intercepts. If you go to the function that we were dealing with, this function was going to cut the following values. It was going to cut it was going to cut the x-axis at x equals 2 and at x equals 1. That's where this function was going to cut. The one we did. Okay, so in this case, if your function does not cut your x-axis, there's no solution. There are parabolas like that. For instance, x squared plus, say, plus 2. How do you factorize this one? Mamswan.
So would it not be x minus 1 and then x minus 1 as well?
Okay, is this the difference between two squares? First of all, is it a difference?
No.
So if
Yes.
it's not a difference, do we have solutions?
No.
Yeah, no, we don't have solutions. So that's a typical equation for graphs like this one. They don't have solutions. You won't find them. The solutions are not real. But there are also some graphs whereby it will only cut once. So how do you think the solutions will look like? Let's say if it's cutting at 1.
Will it not only have one solution?
Which is going to be x equals 1 or x equals 1.
Negative.
You agree? So, okay, given that x minus 1 or x minus 1 equals 0 or x minus 1 equals 0. I told you that if you want to factorize, you can do this. Okay, do you agree that this can be expressed as x minus 1 squared?
Yeah.
So this is the second observation that you will see, is that all the binomials, all the square binomials, cut the x-axis or at one point. All of them. They only have one solution. And then when your graph digs deeper, like this one, it will cut twice. So if it cuts twice, it means it has two solutions. So when we proceed, I think on Thursday, you will see how we determine whether your function has two or one solution or no solutions. I'll show you how to quickly check that using an equation. So I think we are running out of time. I will see you guys tomorrow. In fact, I'll see you guys tomorrow in our physics lesson. Then I will also see you guys on Thursday. I'm also gonna teach on Friday, maths. So we're gonna continue with maths on Friday from where we left off.
So
All right. Any question?
No, sir.
Okay, so I'll see you guys tomorrow.
Okay, bye.
bye.
Yes.